Okay, starting from a new scene, first and foremost, it's all blank, blah, blah, blah. So I'm going to come over to the asset store and import SteamVR. SteamVR plugin. Alright, and I've already downloaded it, so import. Apparently in the tutorial it doesn't show that it's taking time. I guess I wasn't recording all of my desktop, I was just recording this one scene, so I had to do a couple different videos. Anyway, right now it's importing. Doesn't really look like it is, but it is. Just wait a couple minutes. Okay, so once it imports, you'll need to make sure that you select import all, first and foremost, and then you'll also need to select accept all. So once we've added it into the project into our scene, we'll then be able to, or once we've added SteamVR into our scene, we'll be able to add in a couple other things that we're going to need. I'm going to add in the Vive teleporter, and then I'm going to add in our land for now. That's the land right there. Beautiful little land. And we're going to come over to prefabs and camera rig. Once again, that was under SteamVR camera rig. And that's basically the actual camera rig on what everything's going to be, the controllers, etc. Yeah. So once all that's there, got a controller left and right. Alright. So yeah, we'll open up the camera rig. We're going to add in a couple of things. Basically, so the Vive teleporter stuff, it requires a view controller, which basically makes it so that you can control the rotation of the grid when you teleport. We're also going to add in a little cube. It'll be the proxy dinosaur for now. And in the video, I freeze the rotation, but it's not 100% necessary. Or actually, that rotation for the block is. Otherwise, it'll fly all over the place when you jump on anything a little bit uneven. So this land, I've got two different meshes. One is the actual mesh itself, and the other one is the land mesh, which is just the ground, which is a considerably lower poly, and made it so I could specify exactly where I want to be able to teleport to. So I'll be turning off the mesh renderer for the sake of it. So turn it static, and we're gonna bake that to make that the nav mesh. It takes just a second. Oh, I have to save my scene as well. So saved scene, nav mesh, and ta-da! Now we've got a nav mesh. So now we can start actually doing Vive teleporter things. So we'll open up the Vive teleporter screen or folder and go into the prefabs folder. Import the nav mesh and the pointer. So the pointer is the object that we'll use to actually be the pointer itself, the little beam and such. Then we're going to come into our camera rig, open up the eye itself, so it's under head and then eye, and drag and drop the Vive teleport Vive script onto that. In that, I'm showing off that two different things. The head becomes the eye, basically. So yeah, drag the Vive teleporter onto the eye, pop back over to the inspector. It's got all these things that it's requesting. So we'll add in pointer is the actual pointer. Origin transform in this case is going to be the camera rig, and that's used for the teleportation mechanic. The head transform, that's basically you get the head and the origin so we can determine where we're going to be when we teleport. And nav mesh animator. That's what's going to bring up the grid when we click. And then view controller is that right there. And then we'll come back over to assets, back to the Vive teleporter, and we'll open up our art. Let's go over to the nav mesh first. We've got a border renderer, so we're going to drag the room area border over to the border renderer, and Then we're going to hop back over to the eye and grab the fade black and pop that into the Vive, teleport Vive script. That'll make it so it actually fades out and fades back in when you teleport. And we're going to put the room area border on that one as well. Okay, and name the cube to Dino, because why not? Rotate it around so it'll be facing forward when we do it. Oh, and pop over to the pointer, and the pointer needs a nav mesh. So we're going to grab the actual nav mesh and put it on there. The nav mesh prefab and put it into the parabolic pointer script. Okay, so that's all good there. And we will be coming back over to the camera eye, the script on the camera eye, the actual Vive teleporter, in a minute. So that, as you can see, once we've added in the nav mesh, it makes it so that the beam pops out and goes all the way down to where the actual nav mesh is going to be. And the little ball, green ball, is what's going to be like the little circle at the end. Anyway, so in the script, we're going to be selecting on controllers and adding a controller in just a moment. We're not going to do that just yet. First, we're going to come back over to the nav mesh, and we're going to update nav mesh data. So you'll see it renders out like that, and we've got no real slants, it's just like triangles and such. So the reason that happens is because we didn't click on ignore slope surfaces. We want to remove that for now. And when we remove that and update the nav mesh again, now we'll get a nice slope, but if you notice, it can't do really close together, like really janky terrain. And it's having a little bit of an issue right here, but if you'll notice, it is still there and it'll still work. It's just for some reason the mesh is messed up right now. And it's right there too. But if you'll notice, it does that downward slant pretty well. It's a bigger slant, and so it can handle it fairly well. Again, I'm not really sure why that's working like that. It's got to be like a mesh issue. I tried turning off the land mesh renderer, and it still does it. So I'm not really it wasn't showing up previously, but in this tutorial it's showing up, so whatever. That's just an issue with my model itself. The scripts themselves work just fine in this case. So if I click play, nothing happens. I click on the touchpad and nothing will happen. And so the reason why that happens is because we did not select to add in the controller. So what we want to do is we want to come over to the camera eye, and over to the Vive teleporter script, and click on controllers. We're going to add one in. We're going to add in one of the left and right controllers. Right now I'm going to add in just the right hand controller, because that's the only one I have on right now. We'll turn on the left hand controller in just a minute, and then we'll still only use one, but we'll change it out. So if I click play, now when I click it, it actually sends out the beam along the nav mesh, and if you'll notice, the little so that box is sort of rotating, but it doesn't rotate all the time. So you have if you push and hold for 2 minutes, it'll actually rotate. Otherwise, it doesn't rotate. But as long as you hold for at least 2 seconds, I said minutes, 2 seconds, it'll actually rotate now, and allow you to rotate and determine the direction you're going to be looking. So we'll go ahead and stop that, and close that out. It's going off the nav mesh. So we're going to come over to the Dino, and we're going to create a couple of game objects. First, we'll create an empty game object, and we'll also create another game object. First, we're going to move that forward. This is going to be kind of like the nose, and so that's what we call it, nose. And we're going to create another one. This time, we're going to create a cube and scale it down a little and put it in front. So I called it the nose, and really it's the bullet. In this case, it's going to be the bullet. So it's going to be what we're shooting. Really, it's less like a bullet. It's more like a cap gun, basically. It shoots out and then hovers and then jumps back to where the nose is. The main reason I put that in was originally just so I could determine where the front was, and then I was like, hey, let's make it an actual gun. Or let's make it so it's a physic and add more to the tutorial. So we're going to add in a rigid body, remove the gravity, add kinematic, and here I put in change the to freeze the rotations. It's not really necessary though, so I remove them. We can, and it's probably a pretty good idea, but we do reset it every time we send it back, so we don't necessarily need it. Okay, so that's our dyno. We've got that little beautiful little dyno there. Okay, so now we've got the teleporting and such working. We've got this nav mesh worked out. Everything's good to go. So all that's left now, let's make some scripts. So now you have so you know how to set it up as a basic scene. Let's make some scripts so that we can change things and do things that we want to. So we'll make a quick script, call it the controller, and I'm going to open that up. Alright, so we've got this script. I deleted everything out and I added these things in. It gets the tracked controller, tracked object, and the device. Those are all going to be pretty important, each one for their own separate reason. Well, basically, the controller and tracked object will be used for all the movements. The device is going to be used for the getting where the location of your thumb is. So I'll go ahead and click play. Okay, so let's add in all the things we're going to be needing for this script. So we've got a public vector 2. And then we're going to call this touch spot. And that's going to store where our thumb is eventually. And then we're going to make a public game object. We'll name it dinosaur or dino. And we're going to need a public game object bullet. And then we're going to make a public transform and name it nose. Public float and move speed. I probably don't need to list all, actually say everything I'm typing out. I'll say it anyway. Public float rotate speed. We'll need a public float jump speed. A public float bullet speed. And we'll set it to an arbitrary 500. Again, makes it just shoots out and comes back. It doesn't ever repeat itself, so I'll show you what I mean in a second. You can obviously fix that, but I'm lazy. So then we're going to make a public float. We'll do a frame count, basically. And so I'm using this for determining how often the dinosaur can jump. And we're also going to float jump amount, how long it's been jumping and such. We're going to set them, but we're never actually going to increase jump amount. Turns out you don't actually need it. So anyway, we'll do a public bool touching, and we'll do a public bool pulling trigger. Oh, we'll do a clicked first, and then a public bool pulling trigger actually. Okay, that's all the public, that's everything that we're going to need right there. Okay, so let's go ahead and start actually writing some functions. So we've got a private void on enable. We're using that so that it doesn't, so every time we turn the controller off and turn back on, it'll actually run. And the reason that's important is because we're going to be getting values and we're going to be subscribing and unsubscribing. So we're going to do a controller, and we're going to do get SteamVR underscore tracked controller. We're going to do the same for the tracked object, but instead we're going to do SteamVR tracked object. So we'll have to do equals get component. And lastly, we're going to set the device to equal, actually, sorry, we're not going to be setting the device at this time. Now we're going to go ahead and subscribe and make subscriptions to handlers. So we're not going to create the handlers just yet. We'll go ahead and just use the auto create function because it's faster. So we'll do a control_controller and then an auto fill in trigger clicked plus equals handle trigger clicked. And that'll be the handler for it when we pull the trigger. We'll do an _controller dot trigger click or dot trigger unclicked and plus equals handle trigger unclicked. We'll do a _controller and we'll do dot press or pad touched actually. We'll do pad touched for now and plus equals handle pad touched. Controller.pad untouched. Or it's unclicked is what it's called. Actually, there is an untouched. I'll go ahead and create the handler and such for this real fast anyway, because why not? And we'll do, and make sure that it's capitalized for the pad touched, otherwise it won't autofill and it won't work. So anyway, you're going to do _pad clicked, and we'll do a handler for that, _pad clicked. Okay. Now, so I'm recording the audio after I already recorded the video because it didn't record my audio. I just realized I never created a controller for the pad untouched. Instead, I did unclicked twice, which in this case, the handle the only thing that'll change is instead of pad unclicked on line 32, you'll want to make sure that you select pad untouched. All the rest of the code should still work. And then anyway, we're going to create the touching equals false, and pulling trigger equals false, and clicked equals false. And then if you highlight over in Microsoft Visual Studio, it allows you to auto create the templates. Now, if you don't, what you need to make sure that you put in is the private void handle unclicked, and then the object sender / clicked event args e. Those are required. If you don't put those in, it won't work right. So let's come over to the handle pad touched, and we'll select touching equals true, or we'll select touching to equal true, and then handle pad unclicked and clicked equals false. Make sure you put that in the unclicked section, and handle pad clicked is going to make it so clicked equals true, handle pad untouched, touching equals false, and trigger clicked and such, we're going to do pulled trigger equals false, and pulled trigger equals true. Okay, under the unclicked, trigger unclicked, I'm going to set the frame count to 0. And then we're going to go back up to handle pad touched, and we're going to start a coroutine, name that coroutine move controller, and it's red because we haven't set up the coroutine. So let's go down and create the coroutine. So I use autofill. I don't like it there, so we're going to delete that, move it down because I'm lazy, and we'll just do enumerator and name it move controller. And we'll put in yield return new, and normally we do wait for seconds, but we're going to do wait for fixed update. Basically, the reason we're using that is if we call this coroutine so it's recursive, basically it'll act like fixed update, but it'll only run when we've started the coroutine. And in this case, we only start the coroutine either recursively or when the touchpad is held. So now we're going to check what the device is, or we're going to set the device. So device is going to equal the SteamVR underscore controller dot input, double parentheses, we set it as an int, and then I'm going to truncate to an int, and then tracked objects dot index. There, perfect. So the reason we're doing that there is so that every single time it updates, it checks where your thumb is at. And then we're going to set touch spot. Took me a minute to find it. And we're going to set that to equal a new vector 2, and we're going to do device dot get axis dot x and device dot get axis y. Alright, let's make it recursive. So we'll do if touched, or if, actually we're not making it recursive right now. We're going to first make it so that it will do stuff. We're going to check to see if you're actually touching it. So if touch spot does not equal 0, 0, we'll do a new vector for that. Then we want to move and rotate the dinosaur. So we're going to do dino.transform.translate, and then we only want to transform on the z-axis in this case. I suppose you could do it so it transforms only on the x-axis, but in this case I want to do just the z-axis because I like z, and why not? So we'll do 0, 0, and then we're going to do touch spot dot y times move speed. Put that into parentheses real fast. Technically you don't need it, but it's a little bit more specific, so I like it. And times time.delta time to smooth it out and end that line. So now we're going to make it so it can rotate. So we're going to do dino.transform.rotate. Actually, sorry, it's rotation. Delete that. No, it's not rotation. It is rotate. So transform.rotate, and then we're only rotating on the y-axis. So we're going to do 0, and then touchspot.x times rotate speed times time.delta time to smooth it out, and then comma 0. Cool. And that's that. Now, perfect. Now's when we make it recursive. So it'll keep calling itself when it's done. So we're going to do if touching start coroutine move controller. Alright, now that will call itself every single time as long as touching is true, which we've set touching true as long as it's touching, as long as you're touching the touchpad. If you let go, it sets touching to false. Okay, so now we've got the scripts written up and such, and we're going to select the right controller, and we're going to put the controller script on the right hand controller. And that's just personal preference. So let's put the dyno under dyno, bullet under bullet, nose under nose. We're going to set the move speed to 10 for now, and rotate speed to, let's say, 90. Jump speed is, let's say, 10. That's a good amount as well. Bullet speed will keep, frame count will keep, and then jump amount, we'll set that to 2. And then another important thing, we need to add in add component tracked under SteamVR underscore tracked controller. If we don't add it in, this controller script will do nothing. So let's click play, and touching the touchpad, oh, moves around super fast, spins around super fast, and it's gone. Okay, so we'll pause that and change that to, let's say, 5, and 45, and 5. So I guess yeah, so, and turn that down to 5. Now we'll press play, and touch the touchpad, and it moves. And it moves pretty quickly, and it smooths in, smooths out. And it's gone again. It's gone. Alright, and so we're done with moving it now. So let's pop back over to Visual Studio. Okay, so here in the code, we've gone ahead and finished up all the controllers. So now let's make it so it can do more things. Let's make the cube so it can jump. So in order to do that, what we're going to do is we're going to create another IEnumerator, coroutine, and enumerator, and name that move controller, or we're going to name that jump. I already did move controller. So jump. And now this one's also going to be recursive, and we want it to act like fixed update. So we're going to do the yield return new, wait for fixed update, and then we want it to jump. So on the y-axis, so dyno.transform.translate, and we want it to go vector3.up, which makes it shoot up, and then times jump speed times time.delta time. That'll help it smooth it out and get it going so it does it well. And once we've done that, we then need to make it a little bit recursive in of that we're going to do an if clicked equals true, or it is recursive, it's just conditional recursive. If clicked equals true, and the frame count is less than the jump amount, then we want it to call the jump coroutine. So start coroutine jump. All right. Start coroutine jump. And that's good there. So now we just need to scroll back up to the handle pad clicked. That's what's going to make it jump when we click down on the touchpad. So we'll click on that and enter start coroutine jump. And that's good there. Alright, so before we hop back over to Unity, because I know this is going to work, let's go ahead and scroll back down to the coroutines that we've been writing, and let's write one more. We're going to write the shoot coroutine, or shoot gun. So IEnumerator, shoot gun, excuse me, and we're going to do yield actually, so we don't need the yield return new. Or we do need that, but we don't want the fixed update one. So for now, first we're going to do bullet.transform.translate, and we're going to shoot it really fast forward. So we're going to do vector3.forward. That'll choose the forward of the object, and from dot forward, there we go. And then we're going to times it by the bullet speed, which is 500, so it'll shoot really fast and go pretty reasonably far, and then times time.delta time. And this is only going to happen once. So it's not really going to be slowed down or anything. It's just going to, so time.delta time is not entirely necessary here. It does help make it so it doesn't go quite as far, but it's just good. Well, I just put it in because, why not? So once we've done that, now we'll enter in the yield return new, wait for seconds, and let's just do 1 second. And then once we've waited, now we want to have the bullet come back. So we'll do bullet.transform.position, and we'll have it equal the nose.getComponent, and we'll do the translate.position. Transform.position. Alright, and so we reset it to be the same position. Now we need to make it sure that it's the same rotation. So we're going to do nose.transform.position, or sorry, we're going to do, so the nose.transform.position, it doesn't actually work because we're calling the transform as well. If we just do nose.position, it'll work because it is a transform. I'll deal with that in just a second. I'll go ahead and fix that. Back here, we're going to do bullet.transform.rotation. Actually, we're going to do bullet.transform.local Euler angles. And that's the actual rotation of the object, not the rotation. Rotation is a quaternion. Local Euler angles is a vector 3, and that's what we want here. So we're going to do bullet.transform.local Euler angles. Once again, we could actually go back and do rotation, not rotate, which would be a quaternion, and we wouldn't quite get what we want because it's weird. Anyway, so yeah, local Euler angles, and we'll continue on. We'll do nose.local Euler angles, which we can do because nose is a transform. So once again, nose is a transform. So we'll come back down, and we'll just do nose.position. Okay, and that will make our bullet shoot and come back to us. That doesn't really like keep shooting, it just like shoots. It'll stay there for a second and then it'll come back. Every time you pull it, it'll go a little bit further, but since it's 1 second, it can't really go super far unless you're super fast. Anyway, so there's just one more thing that we want to add in here before we finish up. Oh, I'm sorry, we need to add in, let's see here. Oh, first, let's move frame count back to where it needs to go. I put it in the wrong place originally. Sorry, I keep getting ahead of myself. So we're going to put it under handle pad unclicked. Right there. Okay, and then under trigger clicked, because we don't have anything to make it shoot, so pull the trigger and start coroutine. It starts the coroutine shoot gun. So when we pull the trigger, it'll actually shoot. Alright, now we're done with the shooting process. Now let's take the onEnable function, and I'm going to move it down below all of the handlers, but above the coroutines. And we're going to change it from onEnable to onDisable. So basically, this is when we're turning off the controller. And when we turn off the controller, we don't need to get those components, so we'll delete those, and we're going to change the pluses to minuses. Basically, this is unsubscribing from the handler. So if the trigger gets pulled, then nothing will happen. Again, it's off though, so nothing could happen anyway. It's just a good way to clean up your script. Let's delete those, and that's it. That's everything. All right, so one more thing though. So when you switch back, so save this and go back to your Unity profile and click on the head and then click on the eye, so with the one that has the Vive teleporter script on it. And you'll want to drag the left controller down to the controller instead. And the reason you'll want to do that is because otherwise, every time you click to make the box jump, it'll also let you teleport, and vice versa. So every time you click to teleport, it'll make you jump. So that's why we put the thing that makes it so you teleport on the left-hand controller, because that's not the one that has the script on it. And from there, you should be all set.